Yes, Subodh, I am audible to you. Yes, I am audible.
Yes, sir.
Yes, let me start. Best introduce yourself.
Sir, I am Shubhat Mandal. I am from Jalpaiguri of West Bengal. I have completed my graduation from University of North Bengal, and then I have completed my post graduation in chemistry from Indian Institute of Technology, ROPAR. And thereafter, I have been preparing for UPSC CGSE for 4 years. So my hobby is singing and traveling.
Yes, good. Last day we have discussed any topic. Any topic?
Sir, no, sir. Actually, complete. I was giving my interview from whole syllabus randomly, sir.
Yes, yes, today. Yes, basic we have discussed in the last day. Yes. Today new topic is analytical chemistry. Yes.
Yes, sir.
What the main application of analytical chemistry? Application.
Yes, sir. Analytical chemistry deals with the qualitative and quantitative analysis of a chemical. Number two is this is applied in the field of R&D, research and development sector. And sir, third one is for a research purpose, we use the analytical chemistry. Where the various analytical techniques are used for academic in research purpose, and basic chemistry is understood by the help of the analytical chemistry. Sir.
Yes, analytical chemistry is a basic point is qualitative, quantitative, volumetric, grammatical, instrumental analysis. Is what the difference?
Yes, sir. Qualitative analysis deals with the detection of different types of cations and anions or different kinds of molecules, either it is organic or inorganic, etc. And quantitative analysis deals with the amount of of a particular chemical or substance or the cation or anion. And the volumetric analysis is used to find out the concentrations of a particular acid or base with the help of the other the acid and the base using the suitable indicator, etc.
What is flame photometry in analytical chemistry?
Okay, flame photometry generally used in case of the atomic emission spectroscopy. A sample taken in of liquid in the liquid phase are vaporized into its corresponding atomic state, and then the electrons are excited of the excited of the atom. The excited electrons come to its ground state and emits a characteristic radiation by which we can detect a cation or atom. Elemental analysis are carried out by this process. This is called the flame photometry.
Next one is atomic absorption spectroscopy. What's the difference between AAS and emission? Atomic and emission. What the difference?
Yes, sir. In case of atomic absorption spectroscopy, the radiation is applied to the sample to the atomic sample or elemental sample. Then the energy absorbed, the amount of energy absorbed is recorded by the suitable detectors. Then the absorbance is plotted with the versus with the versus the wavelength of the absorption. And, then this is detected by this way. This is called sir, atomic absorption spectroscopy. And in case of atomic emission spectroscopy, firstly the atomic samples are excited to its excited state, and the atom comes to its ground state. Thus, characteristic radiation emitted by it, the emitted radiation then analyzed by suitable detector. This kind of analysis is called the atomic emission spectroscopy. And the atomic absorption spectroscopy are generally continuous, and a broad spectrum are we are getting to broad spectrum. And in case of the atomic emission spectroscopy, the sharp spectrums are observed. In case of the atomic absorption spectroscopy, due to the ground state population, higher ground state population are observed. But in case of emission spectrum, the amount of excited elements are relatively smaller. So, sir, the excited so, sir, we need larger temperature to excite more and more atoms to get the sharp and suitable intense lines, sir.
Yes, what the difference between ICP and atomic emission spectra?
Sir, I think, sir, atomic emissions, ICP, I don't think so, sir. Atomic emission spectroscopy is a different thing of ICP. I think, sir, ICP is a part of the atomic emission spectroscopy. ICP generally large amount, generally 7,000 degrees centigrade is applied in case of inductively coupled spectroscopy.
Yes, inductivity coupled plasma. Yes, ICP.
Yes, sir.
Yes. Any drawback limitation of ICP, atomic emission spectroscopy?
Atomic emission spectroscopy is used to analyze more than 70 elements. So I think, sir, it does, and it gives results with desired accuracy. So, sir, I think, sir, it is very suitable, and and the lighter elements cannot be analyzed suitably. For example, gas sample, these cannot be analyzed by this technique. But higher elements, higher atomic weight elements can be analyzed by itself.
The drawback of atomic emission and absorption spectroscopy, drawback limitation, disadvantage.
Yes, sir. Yes, sir. Atomic, I think, sir, Geological Survey of India, they uses most of the cases, they uses the atomic emission spectroscopy because of the desired high degree of accuracy, sir. But we can tell it, we can call the ICP is a drawback for the higher costing, I think so, sir. And the gaseous, so the lighter elements, for example, H2, helium, etc. elements are can be analyzed by the ICP, but cannot be the desired accuracy cannot be find out by it. And in case of the atomic emission spectroscopy, the temperature is lower. In this case, temperature is applied is lower, and higher error can be observed by itself. And background emission and Zeeman correction should be done for the atomic absorption spectroscopy. But in case of the emission spectroscopy, we don't need too much of the background correction, sir. And in case of the, for example, sir, the base metal analysis. In case of the base metal analysis, mainly for the high costing, mainly flame photometry are used, and mercury. So, for example, sir, mercury or arsenic samples, and antimony samples are used, are analyzed by the vapor generation technique, sir, not the ICT technique, sir. So this may be the limitations of it, sir.
Yes, good. Next one is chromatography. Yes, what is the main application of
Yes, sir.
chromatography and how many type of chromatography?
Yes, sir. Chromatography can be used to separate separate the elements or substances from a mixture, and it is used for the used in the R&D department or organic chemistry department or biochemistry department, etc., sir. And various kinds of chromatography can be used, sir. For example, absorption spectroscopy, absorption chromatography, then so partition chromatography, and gas chromatography, liquid chromatography, etc., sir.
Yes, chromatography is type is how many type of chromatography?
Uh, Generally, sir, four types of I read, sir, four types, sir. I think, sir.
Chromatography is the
There is
five type. Absorption chromatography, partition chromatography, ion exchange chromatography.
ionization chromatography and pore penetration chromatography, sir.
Yes.
Sir, in case of, sir, I think, sir, in Robinson's book, I found, or sir, Scoop's book, I found, sir, four types of chromatography, sir. Basically, the classification. For example, adsorption, partition, ion exchange, and pore penetration chromatography, sir.
Exclusion
Then part
and
adsorption.
exclusion and electro. Five type of classification of chromatography: absorption, partition, ion exchange, exclusion, and electro. Five type of
Okay,
chromatography.
sir.
Yes.
Okay, sir. Okay, sir. Okay,
First is absorption chromatography. Absorption chromatography. Yes. How many type of absorption?
okay, sir. Adsorption mainly works with the principle of the adsorption phenomena of the molecules. When the two or more substance have a different van der Waals attraction of force, van der Waals attraction force, um, then these mixtures are passed through the column bed, and different due to different van der Waals or hydrogen or a different kind of van der Waals of force of attraction, they are uh, attached with the column bed for a different kind of a different degree of attraction. So by this phenomena, we can extract the elements or substance from the mixture, sir. For example, TLC, thin layer chromatography, is a adsorption chromatography, sir.
Adsorption chromatography. How many type adsorption?
Um, Sir, I think, sir, I wrote with a thin layer chromatography, sir. One type of answer.
Adsorption chromatography is two type: Coulomb method and gas solid chromatography. Partition chromatography is the
Yeah,
four type: liquid liquid partition, paper chromatography, thin layer chromatography, and extraction chromatography.
sir, in case of, sir, Scoop book, sir, I found a different kind of classification, sir.
ये
For
डिफरेंट
example, partition
सब
chromatography.
बुक में अलग अलग दिया हुआ है, सब में अलग अलग दिया हुआ है, ऐसा नहीं है। लेकिन ये टाइप्स यही है, किसी में कुछ दिया है, किसी में कुछ दिया हुआ है। आपने किससे पढ़ा है?
ठीक है, सर।
विच बुक यू
सर,
फिर?
मैंने तो चार किताब से पढ़ा, सर। सर, स्कूप से पढ़ा, रॉबिन्सन से पढ़ा, और इसके बाद सर ध्रुवचरण दास पढ़ा, और गैडी सिस्टम सर,
वोगेल।
टोटल 4 किताब पढ़ा सर मैंने।
वोगेल देखा,
यस
वोगेल।
सर, गूगल भी से पढ़ा सर, गूगल भी देखा सर मैंने। 5 किताब मैं अगर गिनूँ तो सर 5 किताब हो रहा है सर।
जैसे कोई प्रॉब्लम नहीं, वो टाइप्स आप बताते जाओ, कोई प्रॉब्लम नहीं है। इनमें डिफरेंस
यस
क्या है, ये जो आप कर रहे हैं, लिक्विड पेपर, थिन लेयर क्रोमेटोग्राफी, व्हाट द डिफरेंस?
सर, फ्रॉम विच डिफरेंस?
पेपर क्रोमेटोग्राफी, थिन लेयर क्रोमेटोग्राफी एंड लिक्विड क्रोमेटोग्राफी, व्हाट द डिफरेंस?
Okay, sir. The TLC or thin layer chromatography is a kind of adsorption chromatography, and the TLC and the paper chromatography is a kind of partition chromatography, I think, sir. And sir, another you mentioned, sir, I forgot, sir. Another three terms you used, but
लिक्विड
I
पेपर, थिन
forgot
लेयर।
the another.
लिक्विड पेपर,
Liquid
थिन लेयर।
chromatography, sir. Okay, sir. Yes, sir. Liquid chromatography, sir, is a kind of, I think, sir, partition chromatography. But the difference between the um, liquid and paper chromatography is, um, I think, sir, same. Both are same, sir. Because sir, liquid are just sprayed to the paper, and in case of the liquid chromatography, it is a the bed is also sir, a liquid support. Liquid are sprayed to the solid support material, sir. Same thing. Liquid chromatography and paper chromatography are same, sir. I think, sir.
ओके। नेक्स्ट वन इज, इनमें बेसिक डिफरेंस क्या है? जो 5 टाइप है, इनके बेसिक डिफरेंस बताइए आप। ये एडजॉर्सन है, पार्टीशन है, आयन एक्सचेंज है, एक्सक्लूजन है, इलेक्ट्रो है। इनमें डिफरेंस बताइए, इनमें डिफरेंस क्या है, मेजर पॉइंट, एनी वन डिफरेंस?
Sir, in case of absorption chromatography, the van der Waals force of attraction is the main leading factor. And in case of the partition chromatography, the I think, sir, um, the solubility of the sample to different phase is the leading factor, and it is depends on the distribution ratio between two phases. And in case of the ion exchange chromatography, it is that the ions are exchanged, some ions are exchanged by other ions, I think, sir. And the pore penetration chromatography, it is depends on the pore size of the column bed. Column bed, the larger, smaller particles are penetrated to the pores, and the larger molecules cannot penetrate to the pores, but it eliminate by the larger um, by the larger pores, I think, sir.
यस, सम पॉइंट इज राइट। नेक्स्ट वन इज एक्सरे मेथड ऑफ एनालिसिस।
Yes, sir.
व्हाट इज एक्सरे स्पेक्ट्रोस्कोपी?
X-ray spectroscopy can be different types. For example, X-ray diffraction, X-ray fluorescence, Auger electron spectroscopy, and X-ray emission spectroscopy, X-ray absorption spectroscopy, etc., sir. And the in case of the X-ray diffraction spectroscopy, the texture of a sample can be checked by its the diffraction study. For example, the polymers, if we analyze the polymer, if the polymers are analyzed by the principle of its crystallinity, degree of crystallinity. And another technique is X-ray fluorescence. The inner electrons are excited to its higher the energy, or excited to its excited state. Then it comes to its ground state and emits a characteristic X-ray. By analyzing those emitted X-ray, we can find out its quantity and qualitative properties. And in case of fluorescence, again it is some uh, similar to the X-ray fluorescence, I think, sir. The auger electron spectroscopy, if we talk about the auger electron spectroscopy, the higher energy X-ray are used to emit the core electrons. So when the outer electrons come to fill up the inner vacant side, then the characteristic X-ray or X-ray energy emitted. These energies then again collide with the outer electrons to emit the electrons. These kinds of electrons are called the auger electrons. And if the electron comes to again to the same site, previous vacant site, then some amount of energy is emitted, and by analyzing this type of energy, we can get the auger electron spectroscopy.
Yes. X-ray spectroscopy, one term used in fluorescence and phosphorus. What the difference?
Yes, sir. Okay, sir. In case of the fluorescence, the emitted, the excited electrons come to its ground state. Then the energy radiated is energy radiated. We get the characteristic X-ray. This is the kind of phenomena is called the fluorescence technique, sir. And in case of the phosphorescence, the excited energy, that means it comes, it is a singlet state and comes to its the triplet and most stable state. Then the electron comes to the ground state from its triplet state, and the non-radiation, radiated energy comes from it, and if we analyze it, this kind of energy, then we can get the X-ray phosphorescence.
Yes. X-ray diffraction is other topic is Bragg's law. Yes, Bragg's law. Solid state, yes.
Yes, sir.
What is the main application of
Yes,
Bragg's law?
If we talk about the application of the Bragg's law, we can detect different kind of the crystal structure. The geometry and the shape of a crystal can be analyzed, and for example, for a similar kind of element, we can get different kinds of crystal. Then we can find out is it's a different phase. For example, sulfur has a different kind of crystal. For example, the rhombic crystal and the monoclinic crystal sulfur, rhombic sulfur. We can find out the shape and size, shape and geometry, etc., sir, by the X-ray diffraction technique.
The next is analysis of mineral. What is
Yes,
mineral? What the difference between mineral or an alloy?
Yes, sir. Mineral is a natural substance from which consists of different kind of molecules and atoms, etc., sir. And the alloy is a kind of metal, and we can call it as a mixture of two or three metals. And we can also call it the solution of solid and solid metal. But in case of the minerals can be of solid, liquid, and gaseous. But if we talk about the alloys can be only a form of solid. Minerals can be amorphous and crystalline, but alloys are generally these are crystalline in nature, sir.
Yes. Next one is analysis of petroleum and petroleum product. Yes. What is petroleum? So what is the difference between petrol and diesel?
I think, sir, combustion, petrol has a higher degree of combustion energy. Combustion energy is high, and the diesel has lower combustion energy, sir. But in case of the chemical composition, I think I should read once again to understand the chemical composition, sir. Sorry, sir. I forgot it, sir.
Yes, what the beneficial of petroleum and petroleum product in our society and human being? Any 4-5 point?
Yes, sir. Petrol or petroleum can be used as the fuel or fuel for energy sources. In case of and secondly, petroleum can be used for lubricating material, lubricating agents. Thirdly, sir, petroleum can be used for cosmetics purpose. Fourthly, sir, different kind of plastics or polymers created or can be made from the petroleum. Fifth, sir, waterproof material can be made from the petroleum. Yes, sir.
Yes. Any drawback limitation of petroleum and petroleum product?
Yes, sir. Um, I think, sir, these materials are useful. I think, sir, these should not in the drawbacks. I don't think so, sir. These materials have a drawbacks. These are useful materials.
Yes, petroleum petroleum product is so more drawback limitation. No problem. You look them.
Some
You have
materials
to study. Yes.
are poisonous. Sir. Some materials are poisonous.
Yes.
And yes, sir.
The next topic is analysis of coal and coke. Yes. What is the difference between
Yes, sir.
coal and coke?
Sorry, sir. I have to read once more, sir.
Okay, no problem. Next is whole analytical chemistry. What the beneficial point of whole analytical chemistry? Any 5-10 point? Whole analytical chemistry.
Okay, sir. Whole. Sir.
Yes. Whole complete analytical chemistry. Complete.
Okay, sir. Okay, sir. Yes, sir. Yes, sir. Firstly, sir, analytical chemistry are used to understand the qualitative and quantitative analysis purpose. Secondly, sir, these are these techniques are useful for R&D purpose and industrial purpose. Thirdly, sir, these are used for academic research. Fourthly, sir, yes, sir, these are the usefulness of analytical chemistry.
Yes, whole analytical chemistry drawback limitation. Any 4-5 point? Complete analytical chemistry drawback
I
limitation.
think, sir, 100% error cannot be find out any method, sir. So I think, sir, these can be a drawback. The,
Yes, carry on. यस इतना बड़ा केमिकल एनालिटिकल केमिस्ट्री है.
I think, sir, these are
ड्रॉबैक आपको
yes,
चार
sir.
पांच तो आप फाइंड कर सकते हैं ना. इतना बड़ा एनालिटिकल केमिस्ट्री है. ग्रेमेट्रिक, वॉल्यूमेट्रिक, कॉम्प्लेक्सोमेट्रिक.
Yes, sir. ड्रॉबैक क्या सर तो हो सकते हैं एनालिटिकल तो अब बहुत अच्छा चीज है सर. मैं क्या ही बोल सकता हूँ सर लिमिटेशन के लिए.
यस मैं
100%
आपको
एक्यूरेट.
भेजूंगा डिटेल में. मैं जितने ड्रॉबैक वगैरह है वो सारे आपको सेंड कर दूंगा. ठीक है ना.
ठीक है सर. थैंक यू सर.
इम्पोर्टेंस क्या है? व्हाट आर द इम्पोर्टेंस ऑफ एनालिटिकल केमिस्ट्री? इम्पोर्टेंस.
इम्पोर्टेंस तो बहुत है सर. तो
यस बताइए.
quantitative and qualitative measurements can be made by analytical techniques. And for all the research purposes, chemical or biochemical, etc. If we want to research better in a better way, then our analytical skills should be very high, sir. These are important, sir. I think so.
The next other point is spectroscopy. What is UV visible spectroscopy? What the main application of UV visible application?
Yes, sir. The UV visible spectroscopy is carried out by the use of UV or visible radiation. The molecules or the electronic transitions are carried out by the use of UV and visible radiation of a molecule. The electrons come to its ground state and emit characteristic UV visible radiation. By use of suitable detectors, we can analyze the UV visible radiation and we plot the absorbance versus the lambda, that means the wavelength, and to get the information about the molecules. The main application of the UV visible radiation is to find out for example, number one is to find out the conjugation of the molecule. Then two, by observing the intensity of the absorbance versus the lambda graph, we can find out the quantity of a particular chemical or substance. And number three, the functional group detection can be happened by the visible radiation. Thirdly, fourthly, to detect a particular chemical, also can be done by the UV visible spectroscopy. Fifthly, I think the geometry of a molecule can also be also be determined by the UV visible spectroscopy. For example, cis and trans geometry can also be confirmed by the UV visible spectroscopy. Sixthly, I think the yes, sir. These are the applications of UV visible spectroscopy.
Yes, UV. What the selection rule of UV?
Yes, sir. The change of the spin multiplicity should not be happened during the electronic transition. That means delta S should be equal to 0, sir. And another thing, sir, can be, sir, I forgot it, sir. Delta L should be equal to plus minus 1, sir. That means, sir, S to P transition should be happened, and it is allowed transition. And S to S, that means delta L to where delta L equal to 0, it should be forbidden transition, sir.
Yes, source of UV ultraviolet spectroscopy and visible spectroscopy source.
Okay, sir. In case of the deuterium lamp lamps are used for both UV and visible region because it gives a wide continuum spectrum. And the zirconium, sometimes the zirconium, tungsten filament lamp is used for this purpose.
Yes. Ultraviolet is hydrogen deuterium discharge lamp, and visible is tungsten filament. Is other is a Beer-Lambert law. Is what the main application of Beer-Lambert law in UB?
Okay, sir. The application of Beard-Lambert law is basically, sir, to find out the concentration of a particular substance. According to Beard-Lambert law, the absorbance versus wavelength graph is plotted. I think, sir.
What the formula of Beer-Lambert law? What the main purpose of Beer-Lambert law in UB?
Yes, sir. Log of A naught by A equal to epsilon CL, where A naught equal to A naught equal to initial log I naught by IT equal to epsilon CL. I naught equal to incident radiation, intensity of the incident radiation. IT equal to the radiation intensity of the radiation after absorbance, the absorbance, and C equal to concentration of the substance. Epsilon is the constant, and CL is the length of the sample holder, sir. This is the Beer-Lambert's law. That means, sir, the absorbance of a monochromatic ray by the molecule directly proportional to the concentration of the substance and the length of the path traveled by the radiation.
Yes, drawback limitation of BS law.
A drawback is we have to apply the monochromatic ray, but it is not possible to 100% not possible to isolate a monochromatic ray. The bandwidth of the of a monochromatic ray is very low, so it cannot be possible to use 100% accurate monochromatic array. And sir, secondly, the sample holder should be 100% transparent. The transmittance transparent. It is not possible. Thirdly, sir, during the absorbance, the chemical reaction should not be happen. But sometimes the various molecules participate in chemical reaction during the absorbance phenomena. Fourthly, sir, the Beer-Lambert law cannot be applied for the laser technique. When laser beams are used, the two or more photons are absorbed by a particular molecule. In this case, we cannot use the Beer-Lambert law, sir.
Yes, yes. Three limitations from my side. Number 1 point is solution should not be dilute. Yes. Number 2 point, temperature must be kept constant during experiment. Yes. Number 3 point, there should be no chemical reaction in the solution. 3 drawback limitation in Beer-Lambert law. Yeah, next one is, yes, sir. Beer-Lambert formula is A is equal to epsilon CL.
Yes, sir.
Can you describe of this formula?
A equal to logarithm of I naught by IT, where I naught is the intensity of the incident radiation, and IT is the intensity of the radiation after after absorbance, the rest of the radiation, and the epsilon is the constant, and C is the concentration of the substance, and L is the path length.
Yes, good. Today, good work from